Okay, so in this video, I'm going to be talking about the rate of reaction. This is topic 6 from the unit, and it's actually called chemical kinetics, and I'll explain why in just a second. But this will be part 1 of the video. I'll separate it in 2 parts because it's a lot. So, for starters, we must understand what is rate of reaction. So the rate of reaction is the measurement of how fast or slow a reaction takes place, or how fast or how slow the reactants can change into products. So we know that in every reaction, there are the reactants, which in this case are A and B, and they will form the products, which in this case is AB. So the rate of reaction is the measurement of how fast A and B will become AB. So these are the measurements of the change in concentration of the reactants in comparison to the products over time. So basically it's what is the concentration of the reactants in a solution and how that changes over time. I'll explain more clearly once we have a diagram on, but one thing that it's important to remember is that the rate of reaction is always positive. So no matter if in your calculations you get a negative number, you always have to change it to positive because the rate of reaction will always be positive. So rate of reaction graphs. This will actually make it easier to grasp the idea of rate of reaction. So the rate of reaction can be measured in 2 different ways. The first of them is the rate of appearance, which is how fast the products will appear. So in this case, it's the line that says product right over here. And you can see that it starts from 0, obviously, because the reaction starts entirely with the reactants. And it'll go up and increase because the products are being formed in a reaction. And then there's also the rate of disappearance, which is how fast the reactants are disappearing. So we can see that it starts up here with 10 moles per liter, and they disappear. And you can see that both of these graphs are equal but opposite. So as one increases, the other decreases exactly the same. And since we said that the rate of reaction is always going to be positive, we can see that these values, no matter what you use to calculate, will actually result in the same thing. So the rate is the change in concentration over time. So it's the change in the reactant concentration over time or the change in product concentration over time. And the units for the rate of reaction is mole per cubic decimeter, which is the concentration unit. Moles per liter is the same thing as mole per cubic decimeter per second, because it's a change in concentration per time. So the rate of reaction, as you can see in this example and in this example, they are always curved graphs, or normally curved graphs most of the time. And for this reason, we must be able to understand how to calculate and find the rate of reaction based on a curve. Because if you have a straight line, for example this red line, it's really easy to find the rate, which is the change in volume over time. It's just the gradient or the slope, however you choose to call it. But when you have a curve, it's actually a lot harder to find because you need to do certain calculations. But before I explain how do you do these calculations, I just want to make some general notes. As you can see in this graph, when the reaction is a curved line, or when the reaction is not steep at all, the curve is not steep at all, you can see that the reaction is over. When the reaction is the steepest point, it's where the reaction is the fastest, and when the curve is the less steep, it becomes slower, gradually slower. So you can see here that initially it's super fast and then it becomes slower, and you will be able to explain why by the end of these 2 videos. So now, how do you actually measure the rate of reaction? We can see in this example that we have a curve here, and this is the rate of, based on this graph, we can see that it's the rate of disappearance of the reactants because it's going down. And for you to find the rate of reaction, you must have a certain point. So you can't just find the rate of reaction for the total reaction because it's a curve and you can't do that. So you have to have a certain point you wish to calculate the rate for. So in my example, I'm going to use for 100 seconds. So in order to find the rate of reaction at 100 seconds, you must have a specific point. You have to find the point, so it's right here. You have to draw a tangent line to the curve. So this is what I had on here. Basically what a tangent line is, it's a straight line that will go from one to the other. It'll pass and touch the point, and it's a straight line. You can see that it is equally spaced from here and from here, at least trying to. And basically it'll give you a straight line that crosses that point, and with that straight line you can pick 2 points and find the slope. So I can either pick the y-intercept or the x-intercept or the y-intercept in here, or any 2 points in a line, and you can use rise over run in order to find a curve, which is what we normally do when calculating gradients. So when measuring the rate of reaction, there are 3 things you must remember. The first of them is you must always calculate for a specific point. So in my case, that was 100. You must draw a tangent line to the curve, which is the straight line that has equal distance and passes through the point. And you must pick 2 points on the tangent and find the slope. So in continuation, we can see that there are certain ways to measure rate of reaction. We must be at least familiar with the different ways, and we must understand that the technique you use to measure the rate of reaction depends on your type of reaction. So it depends what the products are, what are the characteristics of those products, and I'll explain a little bit more right now. So the first way to measure the rate of a reaction is the change in volume produced over time. So it's always going to be the change in something over time. The change in volume, for example, the change in mass, the change in light emissions. So the first one is the change in volume over time. So this only works if your reaction produces a gas. So we can see that here there are reactants and they are producing a gas. And what you do is you place a syringe, and as the gas is produced, the syringe will fill up, and you can count, like for example, 10 seconds after the reaction starts, there's 10 dm3 of volume, 20 seconds, there's 15, and so on. So you can plot the different points based on how much volume is gained per unit time. Every 10 seconds or every second, that would be really hard to measure. But the change in volume over time can help you calculate the rate of reaction because you have an increase in the products at a certain time. The second way is a change in mass, and the change in mass once again is only valid when a gas is produced. The reason for that is because the reaction is going to take place on top of the scale, and as the gas is produced, it's going to lose mass, and then you can see the change in mass, or the mass lost over time, and the mass lost is actually the creation of a product. So as the gas is released, the mass of the substance will decrease, and then you can use that to measure the rate of reaction, because you can see that in 10 seconds 3 grams were lost, in another 10 seconds another 3 grams were lost. So you can plot the points and figure out the rate of reaction with your tangent lines. A third way to measure out the rate of reaction is in light transmission. So the requirement for a reaction to be measured out like this is that the reaction changes color as the reaction takes place. So if you have something that goes from white to pink, for example, then you can use the light transmission method. And if there's a change in color, there will be an increase or decrease in absorbance over time. And for this method, you actually need technology, so you can't do it manually. You need, for example, a spectrophotometer, I can never say that, and it'll track the transmittance of light as the reaction takes place, and you can use that to create a curve. A fourth method that you can use is a change in concentration using titration. This method is not really common because it's really complicated. So what you do is that you add single drops of one reactant to another, and then you must use a substance to quench the reaction, which means to pause the reaction. So every time you put a drop in, you have to remove a part of the substance, quench it so that the reaction doesn't continue going, and then you can see how the reaction takes place over time. But it's really uncommon, so I wouldn't worry a lot about this. Just know that every time you put a drop, you have to remove a part of the reaction and quench it in order to measure out the rate of reaction. Another way to measure the rate of reaction is the change in conductivity. So this is only for reactions that produce an ion, because ions increase in conductivity. You will learn about this in chapter 4. And you can use a conductivity meter to measure the conductivity changes in a reaction. I didn't have a picture to put in it because it's something that's really odd, but there is actually a conductivity meter that you can place inside a substance and measure how much it can conduct electricity. And the change in conductivity means that you are creating more products over time. And finally, the last way that you can measure out the rate of a reaction is the clock reaction. This is extremely subjective because how you do it is that you put a X marked on a paper under the substance, and this reaction must change color. and as it changes color, the X will disappear. And once the X disappears, you know that the reaction is complete. So what are the problems with this method? First, it's extremely subjective, because when I don't see the X anymore, might not be when my friend doesn't see the X anymore. A second problem is that it can't actually plot a curve just like, for example, this one can, that you can see that it changes over time, because you can only see the final product when measuring clock reactions. And obviously it's based on the color change. So these are the 6-7 methods that you have of measuring the rate of reaction. You just have to know generally all of them. But the most common ones are definitely change in volume produced with the syringe, and change in mass, and change in light transmittance. So that's it for the first video. I'll go to the second video with the collision theory.